Okay, section 4.3, area of a parallelogram. We're going to start off by asking, what is a parallelogram? Well, a parallelogram is a four-sided flat shape with straight sides where the opposite sides are parallel. First of all, parallel means when two lines run alongside of each other, the same distance apart along the entire line or line segment, which means the two lines can never touch. So if you look at these four shapes that I've put here, I've got my square, I've got my rectangle, and I've got my rhombus. If you look at the four sides on each of those shapes, the sides on this square will continue to go on and they will not ever touch each other. Same with the rectangle, all those sides will do that, and with the rhombus. So, are they all four-sided flat shapes? Yes. Do they all have straight sides? While the rhombus are on a lean, the lines are straight. And are the opposite sides parallel? Absolutely. So on all three of those points are yes. So all three of those shapes are parallelograms. When we're looking into area of a parallelogram, we need to know two specific components. One is the base, and one is the height. A base is any side of a parallelogram that you can choose any side you want. I prefer to pick a flat sitting line. If I was to look at these two shapes, if I had to find a base for both of them, I would choose this line as my base for the rectangle and this line as the base for my leaning rectangle. I find it easiest to choose a line that's flat sitting on my grid lines. That's just me though. You might find it easier to do another way. Try it my way to start. The height. Now the height's a little different. The height is the length of the line segment that joins the parallel sides. But it has to sit perpendicular to the base, which is indicated by a 90-degree angle or a right angle. So the height is any line that I can draw that would connect the opposite parallel lines. This line on the right, this line connects my top line and my bottom line. If we look in the corner, those two lines meet at a 90-degree angle. So in the case of my rectangle, that would be my base, and that would be my height. On the next shape, it's a little bit different. Because my side lines are on an angle, I've already got my base. I'm going to choose the bottom. This line down the middle and the little right angle line tell me that that is going to be my height. Because if I check back through the ideas with my height, it's the line segment joining the lines, and it has to sit at a right angle. So in that case, that would be my height. Sometimes finding the area of an object is simple. When you consider that the area of an object is the amount of space inside of it, which is different than the perimeter. The perimeter is the space on the outside, sort of like building a fence. But the area is how much room would be inside the fence. So in the case of this rectangle at the top, I need to figure out how much space or how much stuff is inside of it. I could just start counting all of the squares on the inside. And that works just fine if you have a shape that is fairly even, just like this. I count all the way across, and I get 21 centimeters squared. But another way to do that is I can look at my base, which is 7, and I can look at my height, which I've counted as 1, 2, 3. And I can put in the formula that area is equal to base times height. If I replace both of those numbers, my base and my height, 7 multiplied by 3, I get 21 centimeters. But I'm not finished here. Area is always written squared. The same can be said for my other shape on this page. If I count across the bottom, I look at how many line segments are being covered up by the line. So there's 1 square, 2, 3, 4, 5, 6, 7. So my base is 7. And then I can check my height. 1, 2, 3. My height is 3. If I do my math, 7 times 3 is 21 centimeters squared. So both of these shapes are the same size. They have the same size bottom and the same size side. So let's try a couple of practice ones here. We're going to start really basic. We're going to say that the base to this rectangle is 4 and that its height is 3. I could go along and draw squares and count them all, but in this case, I'm just going to use the formula that I set up before, that area is equal to the base times the height. I wrote my equation. The second step, like we talked about in class, you have to put in the information that you know. And in this case, we know the base is 4 and that the height is 3. I'm going to do my math. 4 times 3 is 12. I need to make sure that I put in my unit. So in this case, that rectangle would have an area of 12 centimeters squared. Now I move over to the next shape, and it's a little different than the one that we saw on the last page. It's been turned on its side, but I'm still going to use a flat lying edge. I'm still going to use that edge on the flat edge. I don't want to use an angled one. I want to make sure that it's flat. So let's say that it was 2.1 was the height, and the base was 3.5. We're getting back into decimals here. I'm not going to go through and I'm not going to count all the squares on the inside. I'm going to use my equation. And again, a reminder, it's area equals base times height. I write out my equation. And once I've written out my equation, I can do my second step, replace what I know. I know the base is 3.5. I know that the height is 2.1. And I'm going to do my math. Again, you can use a calculator for this. If you're old-fashioned, just like me, and you want to do it longhand, you can, but you stack them properly. We just finished this unit, 3.5 times 2.1. As you do your math, making sure that you've set everything up where it's supposed to go. 3.5 times 2.1. Go through the bottom, adding your zeros. Get all the way to the bottom, you find that it's 7 and 35 hundredths centimeters squared. You have to make sure that you put the centimeters squared in every time. You know how I am about that. You want to make sure that the units are in. You will not get full marks for not having the units squared in. Now this one at the bottom is a little bit different. It doesn't look like any of the other ones because it has its height on the outside. If you look at your two line segments, the line segment on the outside and the line segment on the inside are the same height. In this case, they've chosen to draw it on the outside. And I've chosen to give you an example of that. So, first thing we're going to do is look for our height. So let's say that in this case they gave you the height of 2. And they said that this line from the edge of your shape to the 90-degree angle is 3. And the inside or the bottom of the shape is 4. Some people might be tempted to make their base 7. Some people might be tempted to use the base of 3. But if you look at the shape, the base of this shape is 4. The 3 is on the outside of the shape. The 3 does not give you the actual length of your black line. The 3 is a connector line to show where the 90-degree angle would meet. So in this case, you've written out your equation, and then as usual, you want to make sure that you replace the information that you know. Base is 4, height is 2. And then once you've done your basic math, you'll realize that 4 times 2 is 8. I put in my centimeters squared. On the next section is your practice question. In your practice question, I've given you 2 different alternatives. Or actually, I've given you two different questions, pardon me. The shape, it looks the same, but I've given you different measurements. For the shape on the left, I want you to find the area of the parallelogram. Okay, I want you to find the area of what the area of that parallelogram would be. You've got your base, you've got your height. You need to use your equation. Remember that area is equal to your base times your height. So this parallelogram on the left is going to be very straightforward. The parallelogram on your right, not so much. You have the area, you have a piece of information, you have your base, but this time I want you to find the height of that parallelogram. It's a lot like the last section where we looked at the circumference of a circle, where you had the diameter, but you had the circumference, but you didn't have the diameter. Now you have the area of the second parallelogram, but you do not have the height. So you need to do things a little bit differently. Use the 3 steps we talked about in class. Step 1, write out your equation. Step 2, fill in what you know. And step 3, solve or do the math. Try this question. Have it ready for class.